Hello everyone, welcome to lecture series of Engineering Graphics and Design. Myself Ankur Patel, and today we are going to learn orthographic projections. So in this first session of orthographic projections, we will discuss what is orthographic projections, what are the methods of orthographic projections, and at the end we will also discuss how to draw different views of the given object by using the particular methods of orthographic projections. And before starting today's session, I prefer you to watch my video on projection of points to clear the concepts of projections. And the link of this video is given in the description. So let's start with the orthographic projections. So what are orthographic projections? It is a technical drawing in which different views of an object are projected on different reference planes, observing perpendicular to the respective reference planes. And the meaning of orthographic projection means perpendicular projections, and projection means to draw the front view, top view and the side view of the given object. So what are the different reference planes? So the different reference planes are the horizontal plane, vertical plane and profile plane. So this is our horizontal plane, this is our vertical plane, profile plane. Horizontal plane is a plane which is parallel to the ground. Vertical plane is a plane which is perpendicular to the horizontal plane, and profile plane is a plane which is perpendicular to both horizontal plane and vertical plane. And the reference planes are imaginary and transparent. And what are the different views? So the different views are the front view, top view and the side view. So the front view is projected on the vertical plane, top view is projected on the horizontal plane and side view is projected on the profile plane. So on the vertical plane we will project the front view observing from this given direction. On the horizontal plane we will project the top view observing from the top direction, and on the profile plane we will project the side view of the given object. And in orthographic projections, the projection lines are parallel to each other and perpendicular to the given reference plane, and observer is assumed at infinite distance. Now let us discuss the methods of orthographic projections. So first is first angle projection method. Here views are drawn by placing object in the first quadrant. So if we place the object in the first quadrant, we will get the front view above the XY reference line and top view below the XY reference line. Then after second angle projection method. So in second angle projection method, the views are drawn by placing the object in the second quadrant. So if we place the object in the second quadrant, we will get the front view above the XY reference line, top view also above the XY reference line. Then after third angle projection method. So in the third angle projection method, the views are drawn by placing object in the third quadrant. So if we place the object in the third quadrant, we will get the front view below the XY reference line, top view above the XY reference line. And the fourth angle projection method. So here the views are drawn by placing object in the fourth quadrant, and if we place the object in the fourth quadrant, we will get the front view below the XY reference line, top view below the XY reference line. So in the second angle projection method and fourth angle projection method, as you have observed that front view and top view both are above the XY reference line. That means the front view and top view of the given object are both in the same plane and above the XY reference line, whereas in the fourth angle projection method, the front view and top view of the given object both are in the same plane and below the XY reference line. So due to the overlapping of the views in the same plane, we are not going to use the second and fourth angle projection method for drawing the different views of the given object. So now let us discuss the first angle and third angle projection method, starting with the first angle projection method. So in first angle projection method, the object is assumed to be situated in the first quadrant. That means above HP, in front of VP. And if the object is in the first quadrant, the object is in between observer and plane. And the views are plotted like this. That means by taking the front view as a reference view, the top view will be below the front view, left hand side view of the object will be in the right hand side of the front, right hand side view of the object will be in the left hand side of the front view, bottom view will be above the front view, and we will draw the rear view over here. So these are the positions of different views by using the first angle projection method, or if we are using the first angle projection method, we will take the position of the different views like this. So now this is the symbol of the first angle projection method: top view below the xy reference line, front view above the xy reference line. And to show the symbol of the first angle projection method, we have used the object known as the frustum of cone. So these are the top view and front view of the frustum of the cone. Now let us discuss the first angle projection method by using by drawing the views of this cuboid. So if you want to draw the front view, we will observe the object from this direction. If you want to draw the top view, we will observe the object from this direction. And if you want to draw the side view, we will observe the object from this direction. And right now the visible side view is the left hand side view. So to observe the left hand side view or side view of the object, or left hand side view of the object, we have to observe it from this direction. So this will be the left hand side view. Now to draw the front view, we have to project this object on the vertical plane. So project this object on the vertical plane, and as you know that the projection lines should be parallel to each other and perpendicular to the vertical plane as we are observing the front view. So if we project this object on the vertical plane, we will get the front view over here. So right now the front view is this face. Our front view shows us this face of the object, and it is a rectangle. So this is a vertical plane and this is the front view of the cuboid. Now if we want to draw the top view, we have to observe the object from here, and we have to project the object on the horizontal plane to draw the front view, and we have to take the projection lines parallel to each other and perpendicular to the horizontal plane. So here we will get the top view, and in the top view we will see this face of the cuboid. So this is the top view and this is our horizontal plane. And if we want to draw the side view of this cuboid, we have to project this object on the profile plane. For that we have to draw the projection lines perpendicular to the profile plane, and projection lines should be parallel to each other. So this will be our side view, and in the side view we will observe this face, or we will plot this face of the given object. So this is our side view on the profile plane. And right now you can see that the object is in the first quadrant. That means it is above HP and in front of VP. And if you are taking the object in the first quadrant, it will be in between the plane and the observer. So for the front, if you are observing the front view of the object, the observer will be over here and the object is here and plane is here. So object is in between observer and plane. For the top view also, the object is in between observer and plane, and for the side view the object is in between the observer and the plane. If you want to draw the right hand side view, we will observe the object from this direction. If you want to draw the rear view, we will observe the object from this direction, and if you want to draw the bottom view, we will be observe the object from this direction. So after plotting the front view, top view and the side view of the given object, we have to rotate the horizontal plane 90 degree in the clockwise direction and profile plane 90 degree in the anti-clockwise direction. So if we rotate horizontal plane 90 degree in the clockwise direction, we will get the top view below the XY reference line or below the front view like this. And right now this is our left hand side view. So left hand side we will project on the right hand side of the front view. So here we will get the left hand side view on the right hand side of the front view. So if we draw the right hand side view, we will get it on the left hand side of the front view. If we project the bottom view, it will be above the front view, and if we project the rear view, it will be over here. Now let us discuss the third angle projection method. So in the third angle projection method, the object is assumed to be situated in the third quadrant, that is below HP and behind of VP. So if we will take the object in the third quadrant, the planes being transparent, and it will be in between observer and the object. That means the planes are in between observer and the object. And if we will take the object in the third quadrant, we will get the positions of the different view like this. Taking front view as a reference view, we will get the bottom view below the front view, top view above the front view, right hand side view on the right hand side of the front view, and left hand side view on the left hand side of the front view. And the position of the rear view will remain over here. Now this will be the symbol of the first angle projection method: front view below the XY reference line, top view above the XY reference line. And to show the symbol of the third angle projection method, we have taken we have drawn the views of the frustum of the cone. So this is the top view of the frustum of the cone, and this is the front view of the frustum of the cone. So front view is below the xy reference line and top view is above the xy reference line. So now let us discuss the third angle projection method by drawing different views of the cuboid again. So right now the object is placed on the ground and it is in the third quadrant. We will assume the object in the third quadrant. So if you want to draw the top view of the object, we have to project the object on the horizontal plane, and we have to take the projections perpendicular to the horizontal plane. So on the horizontal plane we will get the top view of the object. So this will be the top view. It is a rectangle showing this face of the object. We have observed the top view from this direction, so this will be our top view. And if we want to draw the front view, we have to observe the object from this direction and we have to project the object on the vertical plane. For that we will take the projection perpendicular to the vertical plane. So now project this object on the vertical plane by taking parallel projections and perpendicular to the vertical plane. Here we will get the front view. So this shape really shows the front view. It is a rectangle and it shows this face of the object. So this is our front view. And if we want to draw the side view, we will draw the left hand side view of the object, because left hand side view is visible. For that we will first of all take the profile plane. This is our profile plane, and we will project the object on the profile plane by taking perpendicular projection to the profile plane, and projection should be, or projection line should be parallel to each other. So here we will get the side view of the object. So right now you can see that the object is in the third quadrant. That means it is behind of VP and below the HP. And for the front view we have taken the observer over here. So an object is here. So you can see that the plane is in between observer and the object. For the top view you can see that the plane is in between object and the observer. For the side view you can see that the plane is in between observer and the object. Now after plotting the front view, top view and the side view, we have to rotate horizontal plane 90 degree in the clockwise direction and profile plane 90 degree in the anti-clockwise directions. So after rotating the horizontal plane 90 degree in the clockwise direction, the top view will be above the front view, left hand side view will be in the left hand side of the front view. So here you can see that the top view is above the front view, left hand side view is in the left hand side of the front view. If we will draw the right hand side view, it will be in the right hand side of the front view. If we will draw bottom view, it will be below the front view, and here we will get the rear view of the object. So these are the positions of different views showing the third angle projection method. Now let us discuss how to draw different views of the given object by using the particular methods of orthographic projections. So here we have taken one question. For the cuboid 50 into 30 into 20, draw all 6 orthographic views using the first angle projection method. Cuboid 50 into 30 into 20, that means the length of the cuboid will be 50, width will be 30 and height will be 20, and we have to draw all 6 orthographic views. That means front view, top view, bottom view, left hand side view, right hand side view and the rear view of the cuboid by using the first angle projection method. So here we will use the first angle projection method. So this figure shows the cuboid having length 50, width 30 and height 20. And right now we will start with the front view, top view and the left hand side view, because the front view, left hand side view and top view is visible in this figure. So front view is observed from this direction, left hand side view is observed from this direction and top view will be observed from this direction. So and after drawing the front view, top view and the left hand side view, we will draw the right hand side view observed from this direction, bottom view observed from this direction and the rear view observed from this direction. So let's start with the front view, top view and the left hand side view. So first of all draw xy line and x1 y1 line, and we have to draw the front view, top view and left hand side view. So if we will draw front view in this quadrant, top view will be below the front view and the left hand side view will be in the right hand side of the front view. So observing from this direction, we will have a rectangle in the front view having length 50 and height 20. So right now the front view is a rectangle having length 50 and height 20. So this red surface of the cuboid gives us the front view. So this will be our front view, length 50 and width 20 mm. So the length of the front view is parallel to the xy reference line and the height of the front view is parallel to the x1 y1 line. Now top view. So for the top view we have to observe the object from the top direction. So in the top view we will get the rectangle again showing the surface of the cuboid. So this green surface of the cuboid will gives us the top view having length 50 and width 30. So first of all project the length of the top view from the front view. So this will be the length of the top view, and now we have to measure the width parallel to the x1 y1 line. Length will be parallel to xy line and the width will be parallel to the x1 y1 line. So this will be our top view having length 50 and width 30. Now we have to draw the left hand side view. So left hand side view will be the right hand side view, and you can see that the left hand side view will be a rectangle showing the surface. This purple surface of the cuboid will gives us the left hand side view having length 30 and height 20 mm. So first of all we have to project the height of the left hand side view from the front view, and the width of the left hand side view will be projected from the top view. For that we will draw a line inclined at an angle of 45 degree to xy line and x1 y1 line, or we will draw a line inclined at an angle 45 degree from the intersection point of the xy and x1 y1 line. Now project the width of the top view over here. So this will be the width. Now project this point over here like this. So this will be the width. So right now the width is projected in the left hand side view. So this box will gives us the left hand side view having a length 30 and height. So length will be, that means the width 30 and height 20 mm. Now if you want to draw the bottom view will be same as the top view and it will be projected above the front view. So first of all draw a line parallel to xy line over here. This will be our reference line. Project the length from the front view above the xy reference line, and now project the width of the bottom view from the left hand side view. For that we will draw a 45 degree line over here, and from this point we will project the width over here. So this will be the width of the bottom view, this will be the length of the bottom view. So bottom view will be same as the top view, which will be a rectangle having length 50 and width 30. So this will be our bottom view. Now we have to draw the right hand side view. So right hand side view will be in the left hand side of the front view because we are using the first angle projection method, and right hand side view will be same as the left hand side view, and it will be a rectangle having length 30 and height 20. So height is projected from the front view over here, and before projecting the height we have to draw a reference line parallel to the x1 y1 line. So this is the height. Now we have to project the width. We will project the width from the bottom view over here. So this will be the width, which is 30 mm. Project this edge over here at the 45 degree line. Project this edge over here, both edge. Here we will get a box showing the right hand side view of the object. So right hand side view will be a rectangle having width 30 and height 20. Now we have to draw the rear view, and here we will be same as the front view. It will be a rectangle having length 50 and height 20 mm. So over here, by drawing the reference line parallel to xy reference line and by projecting the height from the front view or left hand side view, draw a rear view having length 50 and height 20 mm. So by using this particular method you can draw different views of the given object. So after drawing all the views of the object, at the end we have to give the dimensions because dimensions are compulsory. So in the top view this will be a length and this will be a width, length 50, width 30, because top view is a rectangle having length 50, width 30. And here we will give the height 20 mm because in this, that means in the right hand side view, front view, left hand side view and rear view, we will get the height. So give the dimensions of the height over here. it will represents all the height of the front view, left hand side view and rear view. This will represent the length of the top view, length of the front view and length of the bottom view also, and this will represent the width of the top view, left hand side view and the bottom view. So this is it for today. Thank you for watching. We will come with some more problems of orthographic projections in our next lecture. Till then, take care.